Previously, we have learned about the three concepts about the Arduino programming. So the first one is the digital write, second one is the digital read, and then the third one is the for the if statement. So basically, for the digital write, so we use this function to switch on the LED. For the digital read, it was used to read the push button command before switch on the LED light, and then the if statement is used to give some condition for the current state that which part should be executed. So today we will cover up the rest of the part. So the first one is the analog write, second one is the analog read, and then the third one is the serial communication. Basically, the concept of the analog write is quite straightforward. So the aim is that we wish to use the microcontroller to give the analog reading to the output. So let's say we can give the ranging of, let's say, from 0 to 5 volt. So what is the type of output that can be supplied to switch on LED, switch on whatever in the output, let's say control the speed of the motor and etc. For the Arduino, the concept of the analog write is a bit complicated, but basically the analog write function in the Arduino use the concept that we call as the PWM, pulse width modulation. So pulse width modulation is the concept in which the on and the on and off the on and off condition was alternatingly implemented with the different duty cycles in order to provide the ranging from 0 to 5 volt depending on the supply voltage. It can be 0 to 5, 0.2 volt, or and etc. So for utilize the analog read, so we need to look at usually the analog write can only be used in the specific function that defined by the Arduino schematic. So if we look at the board configuration, so for this particular case, the pin that tag with the PWM is the only pin that we can use to generate the PWM signal or the analog write function. So in this case, pin 11, 10, 9, and then 6, 5, and 3. So there is the pin that we can use to generate the analog output. The second one is the analog read. So the same with the analog write. Analog read can only be used in the specific pin as stated in the Arduino schematic. So in this particular case, the analog read function can only be used for this part of the pin, which is from A0 to A5. So we will cover both of the concept, analog write and analog read, in the next example. And then apart from that, I will show how we can use the serial communication protocol, which is based on the UART, to display the reading that we have obtained from the analog read function. So the first step, let's go to the Autodesk Tinkercad. So the same setting, we select the circuit function in the left side of the tab, and then I will utilize the same configuration that we have constructed early. So the same setting, we have one button, one LED, and then we will do some modification from this particular configuration to develop our own function that able to utilize the analog read and also the analog write function. So let's first do the analog write function first. So the aim of the analog write means that for this particular case, if we press the button, so the LED will go brightness, will become brightness depending on the level of voltage that was applied to the LED. So let's do that thing. So basically, first thing first, we need to look at which pin that the Arduino Uno that we can use to plug in our LED. So in this case, we can plug in our LED in the pin number 11, because pin number 11 has the digital PWM function, can support that particular function. So for this particular case, we just move our LED to pin number 11. Just move this thing, then delete this part, and then put it from 11. Okay, so for the button, we will use the same pin configuration. Okay, so we have settled in terms of the hardware part. So the next part, let's go to the coding section. So for the coding section, in this particular case, we can use the same button. So let's say I just set define the PWM pin as 11, so that later on we can just use the previous configuration. We just replace with the PWM pin, so the PWM pin will become output. Okay, so previously if the button is high, digital write 13 high. So if low, then digital write, if button is high, switch on straight away. If not, then switch off the light. So we will replace the digital write function in the high condition to the analog write function. So I just put some curly bracket so that we can modify a bit the coding for this part. So for the analog write function, we need to select the PWM pin. So for this case, the PWM pin. So the same thing for the digital write, we just need to change to PWM pin. Okay, so previously we put for the digital write is either the high or low, but for the analog write, the value can be ranging from 0 to 255. So means that if we supply the voltage to the LED, means that 0 it will be switched off, 255 means that the full brightness, 1 to 5 is the partial brightness, and etc. So if we wish to develop the dimmer function, so we need to use another loop inside of this conditional branch. So for that particular case, I just use the for loop. So let's say for loop is in I equal to 0, and then I less than 255, I less than or equal to 255, and then I just put I plus plus, means that it will be increment, and then the increment value will be plugged in straight away to the PWM pin. So in this case, I just put I here. So it means that this is if we press the button, so it will give the some sort of the small voltage, increment voltage to the LED pin. and then the brightness will become the brightness level will increase up until the full brightness. So to see effect of this particular action, so we need to put some delay. So in this case, let's say I just put delay of 100, which is 0.1 second. So okay, so for this particular case, we need to make sure that we hold the button up until the process completed, so that once we release that thing, the LED will switch off. Okay, we can start the simulation. Okay, we press this button, so the brightness will increase, and then later on it shall be switch off. Okay, it will become much more brightness. Since the delay is 0.1 seconds, 0.1 seconds times 255, so it will require some time to complete the process. So that's the thing that is happening here. Okay, let's say if we wish to see what is the value that was applied to the analog function when we execute the for loop, so we can use the serial command. So serial command is one of the function based on the serial communication. So we can use the serial command to see what is actually happening inside of every loop. So to see that thing, we have the serial monitor here. So the value will be displayed here. So how we can use that thing? So first thing first, we need to set up our serial mode. So stop the simulation first. Okay, then we can start using the serial by typing the serial dot begin function. So give the baud rate, so usually will be the smallest will be 9600. So this is we start the serial communication protocol, and then if we wish to see the value here that was applied to the analog function, apparently we can straight away type the serial dot print. If we just put serial dot print, means that it will print the item in the horizontal manners, stack that thing in a horizontal manners. So if we put the serial dot print ln, so it will be in a vertical stacking of the data, so it will be much more easy to see. So we just put the value of I here. Okay, then okay, seems okay. So we start the simulation. Then if we press this button here, so there is the increment of the I value. So at the same time that value was applied to the analog right function, that later on translated into the voltage representation in the output pin that was supplied to the LED. So after 255, it will stop the function, and then later on switch off the LED light. So if we wish to see what is the amount of voltage that was applied to the LED, so we can use the multimeter. So we can select that things from this side. Okay, multimeter. So multimeter, the red part is the positive, and then black part is the negative. So we can tap the reading from our LED here. So let's say just tap the positive side here. and then later on the negative side. Okay. So we can start to do the simulation once we press this button. Value will increase, and then this is the amount of the voltage that was actually supplied to the LED. So based on the supplied amount of voltage, so it will make the LED become much more bright. So up until the full scale of the voltage that was applied to the LED. So basically that's the thing in terms of the three functions. So we have covered the analog, right, and also the serial communication. So the next part, the analog read function. So for the analog read function, so we can try that thing by using in this part we can use the potentiometer. So potentiometer is something like, okay, this part. So potentiometer is basically the it's just something like the variable resistors, but in a circular motion. So usually the potentiometer will have 3 pins, in which the center of the pin is the output voltage, and then left and the right side is where that we will put the positive or negative. So in general, there will be no polarity for the potentiometer because of is the resistor. So you can put either this part positive or either this part is positive, should be no problem. But the center part of the potentiometer should go to the which part that we wish to read the voltage. So for this particular condition, since previously I have mentioned for the analog pin, so we need to use a special dedicated pin from the schematic. So in this case, we use either pin A0 to A5. So let's say we select pin A0 to read the voltage from the potentiometer. So if just make the connection from A0 to the center of potentiometer. Okay, settle. Next, we need to supply the positive and the negative voltage. So this part goes to the negative, and then this part go to the positive. So let's say we just select the 3.3 volt that's applied to the potentiometer. So let's change this color to black for the grounding. Okay. So we have settled in terms of the hardware. The next part we go to the coding part. So for the coding part, say we define the pin for the analog. Let's say we put it as the potentiometer. The pin will be A0 because this is the analog pin that we use in the hardware setting. So once we select that thing, okay, we can straight away read the digital value from the pin A0. So in this case, in value equal to, so it will be the analog read, ANALOG, analog read, and then the pin will be potentiometer, POT. So this is the value reading from the analog. We can see that thing from, we can use the serial to read the value of the potentiometer. So let's say I just put serial dot print. This is the analog potentiometer reading. Okay. And then we put the value of val. This is the value of the potential reading. Okay, try to do try simulate. So currently the potential reading is 765. So let's say so this is 0. So the full swing will be 675 of the potentiometer. So it will be depending on the accuracy of the analog to digital converter. So let's say for the resistance, we can change the resistance, let's say to 1 kilo ohm. So you can see what is the effect if we change the value of the resistance. Okay, the reading will be more or less will be the same. Okay, so means that this is the ranging of value from 0 to 675. So let's say if I select the value of 5 volt that's applied to the potentiometer, so we can also check the reading. So for this particular case, the maximum value will be 1022, and then the small one value will be 0. So it will be ranging from 0 to 1022. So it will be depending on the amount of voltage that you supply to the potentiometer, so that it can be used to control the amount of voltage that we can supply to the output. Okay, so the next part of this section, so let's dim our light by using the potentiometer, in which if we go with full swing, so it will be full brightness. If low voltage, then the zero voltage of the potentiometer, then the LED will be switched off. Okay, we can do that thing by giving the value of the potentiometer reading straight away to the analog right function. Okay, so for this particular case, okay, we can just select one function here, which is straightaway analog right, the PWM pin, and then also the value here. But you need to remember, because of the analog right function, the maximum amount will be 255, but our input will be 1022. The maximum will be 1024. So what we can do to ensure that the resolution will be tailored between the analog right function and also the analog read function, so we need to divide the value that we supply to the analog right function with 4. So means that the maximum value will be 255. So we can disable the other function here, which is since we don't use any push button, so we can disable this function. Okay, then we can simulate again. Okay, so there's some error. Okay, so it's just a matter of another function. We need to put the semicolon, then start simulation. Okay, so for this particular case, if we change the value of the potentiometer, then you can see the changes of voltage and also the brightness level of the LED. So this is to 0, and then if we increase or we rotate the potentiometer, then the value will become higher and also able to ensure that the light will become much more brightness. So we have covered up most of the pillar of the Arduino programming: digital write, analog write, digital read, if statement, and also the for statement, the analog read, and also the serial communication. Thank you.